Welcome and good day, everyone. My name is Siti Amira, and my project title is Investigating Performance Bottlenecks in a Public API Using Artillery-Based Testing. So this is my GitHub repo. It contains my Python program, my README, which serve as a user manual and my requirement file. At the bottom README, I have included a flow diagram shows how this program works. Okay. From here, my PC act as a client. It sends a real HTTP GET request over the internet to JSON placeholder, TPI code, which is a public REST API server. The server responds with a JSON data, and my program receive and measure the speed of each response. This means that the latency you see in the results reflect the actual real world network conditions, which is not a simulated or fake data. Okay, for this is the actual API that I am targeting. So each request will return as a JSON object like this with a user ID, post ID, title, and body. My program fetch all 100 posts using three different techniques and measures how fast each one completes. So, say, okay, the problem I am solving is which Python execution technique perform best when sending a large number of API requests. I test three traffic patterns. First, the load test, which is a normal sustained traffic of 100 requests. Second is a stress test, which is actually 100 requests to push beyond normal capacity. And then the third is a spike test, which the 200 requests fired all at once to simulate a sudden burst. So I use three Python techniques, which are asyncio, threading, and multiprocessing. For asyncio, this is a concurrent technique. It uses a single thread with an event loop that fires all requests at the same time without blocking, and it never waits for one request to finish before starting the next. The second is a threading, also concurrent, but uses multiple threads via a ThreadPoolExecutor. The the GIL, which is a global interpreter log, is released during the network waiting, so thread can run simultaneously. Third is multiprocessing. This is my parallel technique, where it spawns separate OS processes using a process pool executor, completely bypassing the GIL for true CPU level parallelism. Okay, I already prepared my CMD, which is this directory. Okay, right. So now I will run the program using a Python API performance tester, which is a Python file. I already go into my directory and then just run the file. So let's wait until the end of the result. So as you can see, the program has completed all 9 tests. Uh, so you can see the final comparison table here. This is the final comparison. So this one is auto update into my GitHub. So when I refresh my GitHub, it will be synced with the result. So this is my past. So I refresh back. It will update to the latest result. So as you can see, looking at the results, you can see that asyncio won every single test. For the load test, asyncio finished it. Asyncio finished is around 1 second, while threading took 11 seconds. 11 seconds, and multiprocessing took about 14 seconds. The reason is simple. This workload is IO bound. So we are just waiting for the network to respond. Asyncio event loop handles hundreds of waiting requests in a single thread very efficiently with zero thread of process overhead. Threading adds overhead from managing multiple threads. Multiprocessing is the slowest here because spawning separate processes is expensive. It is designed for CPU heavy tasks and not network requests. So in conclusion, for API performance testing and any IO bound workload, asyncio is the most efficient technique in Python. Multiprocessing should be reserved for CPU bound parallel tasks where the guild is a real bottleneck, and my GitHub repo contains all the source. You can see that my GitHub repo contains all the source code, use manual, actively config files, and test results. So that's all for me. Thank you.